This is Learning Related Rates with Basketball. My name is Professor Lewis, and I'll be teaching you related rates today. Now that we got the introduction out the way, let's get into our first example. When shooting a three-point shot, the ideal release speed should be 5.5365 feet per second, going straight at the rim. Halfway to the rim, at 11.073 feet, the ball should be reaching its maximum height of 20 feet. What rate is the distance between the shooter and ball increasing at the halfway point, considering the shooter is 6 feet tall? The first thing I usually do is write down everything that is given to me. Okay, first in the yellow, we have the derivative of x over the derivative of t equals 5.5365 feet per second. And then we have x equals 11.073 feet. And then we have y equals 14 feet. And we got all of that information from the problem. Now you see what you are trying to find, and that's what is in the blue, the derivative of c over the derivative of t. And another thing you want to do is draw an illustration to give you a better view or an idea of what this problem is about. And to help us with that today, we have one of the greatest basketball players of all time. Not Michael Jordan, not LeBron, not Kobe, but Roman Lewis. Here's him shooting a three-point shot and stop. Now we can add in all our information given from our problem. So as you can see, our shooter is 6 foot tall. Yes, he's 6 foot tall. And the ball is halfway to the basket, which is 11.073 feet and 20 feet high in the air, making a 14-foot difference between the shooter and the ball. All we need to do is find the length of that last side of the triangle to find dc over dt. Now we can transfer this illustration back to our problem. Here we have the illustration drawn with the problem. To find c, we need to use the Pythagorean theorem. Here we have x squared plus y squared equals c squared. We're going to use the values given to find c. Okay, now that we enter our values, x equaling 11.073, 14 equaling y, we simplify c to equal the square root of 318.611. Now that we know what c is, we need to find the derivative of it. So first we have to define the derivative of the Pythagorean theorem equation when x equals 11.073. Here's the derivative of that equation. Now you want to single out dc over dt. Now you can enter all the values that we do have and see that dc over dt equals 4.34 feet per second, meaning that the rate of the distance between the shooter and ball is increasing at 4.34 feet per second at the halfway point. With this information, you can now be as good as a shooter as he is.